So as we begin, you'll see from the title slide, if I can, when I get the PowerPoint up, that besides the Solar System Ambassadors Group, I'm also a member of the St. Louis Astronomical Society. And I mention that because the society, while it hasn't been able to do the public telescope observing sessions that we schedule, continues to help support the library telescope program. And a lot of you may not have heard of that. So I wanted to tell you just briefly, this is a program with over 150 telescopes in the greater St. Louis area, such that an adult who can check out a book can also check out one of these telescopes. And so here is the library telescope. You'll see it's portable enough to be able to be used fairly easily and very robust. So I mention that because if you're interested, most of the libraries, all of them in St. Louis City and County and St. Charles systems, and a lot of the municipal libraries have one or more of these available for you to check out. Mars is in the morning sky now, so you'll have to get up early to see Mars through this telescope, but it's working its way around to the evening sky by the fall. So that's the library telescope program. I'm gonna see if I can get up the PowerPoint.
And while Rich is doing that, I do want to let you know that we will have a little bit of time following Rich's presentation for Q&A. So if you have questions, you can go ahead and jot those down in the chat window throughout, and then we'll moderate those at the end of his presentation.
So the object of this program is to give you a general idea of what Mars is like so that you can be ready when you book your vacation to Mars. And while we will be looking at some pictures from the current exploration of Mars, from the robotic exploration by orbiters and also by the rovers and ground stations, we'll also look forward to humans eventually traveling there, and after the initial exploration part, to visitors. So on we go, and we begin with image credits, and you can just imagine maybe Host Planets Suite, the Mars selection playing in the background when I show you some of the places from which I got the pictures that you are about to see. And you see there are quite a number of the NASA missions.
So we can't see your slides, your screen.
Oh, okay. Let's see. I think what I have to do.
So you want to share screen?
Come back to share screen. And back to the beginning.
Yep, here we go.
How about that?
There we go. Yep, that's good.
Okay.
Great.
Okay, so on we go with the credits, and then on to the program. Okay, so talking about a vacation to Mars might seem like science fiction, as it was only a few decades ago, but it might be closer than you might imagine. There is already a developing space tourism industry. This is an artist's conception of a plan by a company called Orion Span to put an orbiting hotel up in as early as 2022. So they plan to launch in 2021, have a shakedown crew with their staff, and then they can accommodate up to 4 guests at a time for a week in low Earth orbit in the space hotel. And they have plans for being able to expand that facility, adding additional modules as the clientele warrants. The module is about 40 feet long, 43 feet long, and about 14 feet wide, with a crew of 2 and up to 4 guests. And the initial charges for that are only $9.5 million a person. So it might be a little while before they are flooded with applicants, but they are taking reservations in advance already. And we'll see. That can happen as soon as 2022, according to Orion Span. And it'll be the first in a series of commercial ventures in low Earth orbit. This is going to be about 200 miles up in the air. circulating around the Earth in about 90 minutes or so. And then there's been the thought of having tourists out to the moon, and this is an illustration from back in the 1950s of the Hotel Hilton on the surface of the moon. That will be a little bit longer than 2022, but NASA is working on a return to the moon with astronauts as soon as 2024. And they're starting with a robotic mission to the South Pole, but finishing up with an orbiting science platform in 2023, and then 2 astronauts down to the surface for 6.5 days. And that's currently planned for 2024. And we'll see how the schedule goes with that. The idea is over a longer period of time to develop a permanent lunar base, and that work continues even as soon as 2028. And then in the farther distant future, a lunar city and a place for vacationers, among other things. So that's coming up relatively soon. Now it's going to be tougher to go to Mars. Mars is over 150 times farther away at its closest than the moon is. So it's a long and complex journey to get there, and one that we are not quite ready to make available to tourists. But there are plans to send people there, perhaps by the end of the 2020s. So we'll take a look at what your vacation to Mars might be like, with the understanding that it's going to be a little ways into the future. So Mars is a smallish kind of planet. It's just over 4,000 miles across, 4,200, where the Earth is just under 8,000 miles across. So the Earth is about 7 times the volume of Mars and about 10 times the amount of material. And that combination means that the surface gravity on Mars is just under 4/10 of what we're used to here on the surface of the Earth. So a 120-pound person on Earth is only going to weigh under 50 pounds at Mars. So it's a small world, but we're going to see that it's a very interesting world with the kind of features on its surface that are not matched by anywhere on the Earth, and in some cases not matched elsewhere in the whole solar system. So let's get an idea of what it's going to be like on the surface. Here's the weather report. It's almost always going to be cold and clear. Now, there are going to be times when storms come up. They're not rainstorms, of course, they're dust storms, but most of the time cold and clear. It's very cold. Now, Mars is about 1.5 times farther away from the sun than the Earth is. And so it gets a lot less light, sunlight and heat. It also has a very, very thin atmosphere. Barometric pressure at the surface is only about 10 millibars, 1% that of the Earth. It's like the Earth up about 20 miles high. And that means that the atmosphere doesn't blanket the heat and hold it in. So it's very, very cold. The average temperature on Mars is 80 degrees below zero if you were to just grab a spot at random around the planet and around day and nighttime. So it's going to be chilly, winds. Typically it's calm or maybe 15 miles an hour. They can gust up to 65 miles per hour. But remember, the air is so thin that that doesn't cause the kind of wind damage that we would get on Earth from 65-mile-an-hour wind. It does mean that there are features that have been carved by the wind erosion, just like they have been on the Earth, and we'll see some of them. And the UV index is way high. There's almost no air there to filter out the sunlight. So that means by dressing appropriately that when you go out on the surface of Mars, you'll be in a pressure suit carrying your oxygen along with you and shielding from the rays of the sun, including the X-rays that don't penetrate the Earth's atmosphere. So we're going to take a look at Mars, where there's a lot to see and a lot to do. And I'll start, let me take me out of this so that you get a better picture. We'll start with what you're not going to see. So this is let's get the disclaimers in early. We're not going to find a canal leading to a nice Martian city as was envisioned by science fiction writers, particularly back in the late 1800s and early 1900s. On the left is a map of Mars made by an Italian astronomer in the 1890s, Lowell Hess, and it shows bright and dark features. On the right is a composite from the Hubble Space Telescope. And you can see that the general outlines are pretty well captured here. You can make out these kinds of things. Up here, circle called Hellas is the Hellas Basin, and that's up here. So they've got the light and dark areas down pretty well. But in the drawing, you see these thin lines that connect these dark areas, and those are what in 1877 an Italian astronomer named Schiaparelli, he called them canali, and that was translated not as channel, a natural formation, but as canals. And that began the possibility and the thinking and the stories and the ideas about there being a race of intelligent Martians who built canals in order to be able to irrigate their dark areas if they were fields to move what little water is left from one place to the next. And sadly, when we were able to actually go to Mars robotically in 1965 and again in 1969, we found that the canals simply aren't there. They're an artifact of humans trying to look at the finest details possible at the time through the blurry atmosphere of the Earth. So we're not going to be able to see canals. We will be able to see a lot of other interesting things though. So keep an eye on a feature like a big long stripe through here, and then also some circles up here. And there's actually a bigger circle just about off of the picture there. And we'll take a look and see what those are. So first, the view from orbit. There are currently, I think, 6 orbiters, 3 from the United States, 2 from the European Space Agency, and 1 from India, circling the Martian globe and giving us images beginning in the early 2000s that were of pretty good quality. So we do see craters down there, as we see craters on the moon and any other solid surface on the surface system of the solar system, except maybe for a moon of Jupiter's that probably doesn't, that won't have many, if any. We do see some craters on Mars that are different from what we see on the moon or Mercury or the other satellites. Boy, this jumps around on me now, but stops doing that. And the features like this, what they call the teardrop mesa, and that shows us a difference that's due to Mars' atmosphere. This is the wind blowing past the crater walls and scouring out the surface around it. But here in the shadow of the crater walls, the surface hasn't been eroded so much. So you won't see these teardrop kinds of craters anywhere else in probably anywhere else in the solar system. Something sort of like it on a satellite of Neptune called Triton. We do see regular kinds of craters, regular in the sense that they're circles, sometimes with little bumps that are peaks, hills, or small mountains in the center, as we see on the moon very easily, even through a small telescope. This larger one in particular is called Gusev crater. It's about 100 miles across, and that's where one of the NASA rovers, the Spirit rover, landed in 2004. So craters, some deviations from the regular shape. This is the smiley face crater, and maybe you could see why, right next to a regular one. But this is not, of course, the most famous face on Mars. That dubious honor goes to this Viking picture from the 1970s, 76 or 77, from an orbiter that showed what some people thought looked like an actual human face on Mars. The black dots that are kind of annoyingly all the way through here are just places where the data transmission didn't come through well. So kind of disregard those. But this is supposed to be the face. And Right away, the scientists explained that this is an accident of lighting. It's not a giant statue. And right away, at least a few sensationalist authors said, oh, but it is a face, and went on to claim that they also saw evidence of cities and pyramids on Mars. Well, when we got better orbiters, then the 1970s, about 20 years later or so, 30 years, we got another view, and this is the same territory that you just saw for the face on Mars. So the face is gone. It was an artifact of the lighting. And that just means that the authors are going to have to go on to see something else on the surface. There are so many shapes and forms and craters and landforms that you can see just about any kind of figure that you would like to see. We'll go on to the real features though, and one of the most spectacular is this huge volcano called Olympus Mons, and this is the largest volcano known in the entire solar system. It's more than 375 miles across. That means you could put Missouri and Illinois next to each other. The central pit there, the caldera, is more than 100 miles across. And it's 16 miles tall. So it just dwarfs anything that we have on the Earth. To scale, by one of the planetary geologists who works in Arizona, is Olympus Mons comparing its size to the entire state of Arizona. Just incredible. This is a kind of volcano called a shield volcano, and it's one that's built up by many massive flows of lava over time. It's not an explosive one like Mount St. Helens. It's the same type of volcano as we have in the Hawaiian Islands here on Earth. And that means that while it's huge, and it's 375 miles across, it's a gentle slope. It's only about 5 degrees. And that means for every foot that you would walk up the volcano, you're only increasing your height. You only have to go up 10.5 inches per 10 feet. So you would literally be able to walk up this volcano on your vacation. Now, you probably wouldn't want to walk the whole 160 miles or whatever it is, but you could certainly walk up a piece of it if you're dropped off by your friendly Mars helicopter or dirigible. This is a side view of that from the NASA orbiters, and the height has been exaggerated so that you can see it. The plains of Mars down here, I hope that goes backwards. The cliffs upon which the volcano rests are something like 3,000 to 5,000 feet high, so half a mile to a mile above the plains, and then you go on to the 16-mile high volcano. It's less than, we think, 2 billion years old, and it's not thought to be active anymore. You would want to make sure about that before you started your hike up there. Right nearby, and not by coincidence, is the biggest canyon system in the solar system, the Valles Marineris Canyon System. See if I can stop this from jumping around so much. The canyon stretches for more than 2,500 miles. It's like 10 times longer than the Grand Canyon on the Earth. And it's 30 times wider and 8 times deeper. It goes 8 miles down and goes over 300 miles across at the wider places. Now, the Grand Canyon was carved by the Colorado River by water erosion over time. But this Valles Marineris is formed by the crust of Mars actually cracking, breaking, and pulling apart. And that might have something to do with the large volcano on Olympus Mons and 2 other great big volcanoes close to Olympus Mons that would put a lot of weight and stress on the crust over in this direction. And possibly that caused or accentuated the cracking of the crust. So again, to give you an idea just how big this Valles Marineris is, to scale with the United States, we start off up here, somewhere maybe around San Francisco, that one canyon would run all the way through about Memphis and out the other side to Washington, D.C. So just huge. What a phenomenal place to be able to explore. I guess if you try to take the robot burrow down the side, though, 8 miles is a long way to go down. So you might just want to go down a little ways and then come back up again. We can see structure there. We can see where over time the land has slid down some. We can see where the wind has eroded out and sculpted the sides of this huge canyon system. Here's one small segment of it that again gives you an idea of some of the structure that's in there. The Martian air is actually a little thicker on the bottom of this Valles Marineris, although certainly nowhere near the pressure you would need to be able to function. So there are other features that are also interesting, smaller. Here's a network that looks like the same kind of thing you would get from a river system on the Earth, with smaller tributaries merging to form a larger flow. And it's part of some features that we see on Mars that that strongly suggest or demonstrate that at one time Mars had a lot of liquid water on the surface. And we're interested in several things on Mars. One is the search for life, to see if life had arisen in the past on Mars. And others is to find where the water is so that we can use it when humans get there. So there is some indication from orbit that that's the case. Here's another indication called the chasma. Echos chasma. It's next to a crater, and it's thought that this at one time was the largest body of water on Mars, and perhaps at some point had filled up the crater and then drained back in to help dig out this giant section of the canyon. Well, I didn't want that. There it goes. So if this is what Mars looks like today, as it is, it's another Hubble composite. This is what Mars might have looked like when both Mars and the Earth was very young. We think that there's a strong possibility that there was a lot of water on Mars, that the atmosphere of Mars was much thicker than it is today. Today, as I mentioned, it's only 1% the Earth's atmosphere. It's something like 96% of carbon dioxide, no free oxygen to speak of. So very thin and mostly carbon dioxide. If that atmosphere were much thicker, way back when Mars and Earth were young, 4.5 billion years ago, then it could have retained the heat from the sun and made the surface temperature high enough that water that's now ice, or that's underground, or that's evaporated entirely, could have been liquid. We have maybe some indications of that today. Here is a shot from one of the NASA orbiters. And if you look at these streaks here, these form in late spring and summer, and then they disappear in the late fall and the winter. And so it's possible that these are streaks where water has melted from underneath the surface and just kind of rolled down the side of this canyon. Water that's had a lot of minerals dissolved in it, so it's briny. And the brine, rather than pure water, fixes it so that the liquid, so that it can remain liquid at temperatures somewhat below 0 degrees Fahrenheit, rather than freezing at 32 degrees. So these streaks are indications that there's water on the surface of Mars fairly close to the surface that then seasonally can melt and become visible, as we see. There are other indications as well that we've seen from the rovers that at least at one time there was liquid water on Mars, and then also indications from one of the NASA landers called Phoenix that there is water, at least ice crystals, just a couple inches underneath the surface in at least some places of Mars. There was also the detection of a possible lake on Mars that was made last year. To get a better view and to try to determine how much water is there and where the water is and what the history was, we need to land on Mars. And we did that all the way back in 1976 with two of the Viking landers. They were stationary. But then in the 2000s, we managed to land some rovers that could move around and look for interesting things. So those that landed in 2004 were the Spirit and Opportunity rovers that you've probably heard about. The first rover landed in 1996 as part of a lander. It was only about as big as a microwave oven. It was part of the Pathfinder lander, and that came down on parachutes and retro rockets, as you might expect. But these rovers in 2000 that landed in 2004 were much heavier. They were about 400 pounds apiece, and so they had to have a different landing system. It's a landing system that you do not want to choose when you go there. If you have options on how you're going to land, don't pick the Spirit Special. Spirit and Opportunity began by being lowered by parachute, as you see here in the drawing, and then some retro rockets. But then when they got above the ground 20 or 30 feet, they were cut loose. Airbags inflated that surrounded the rover, and it dropped the last 20 feet or so, 20 or 25 feet. Dropped, hit, bounced, rolled, bounced a couple times, and finally came to a graceful stop. That actually worked, believe it or not. And while they had provision for what would happen if the rover landed upside down, the rovers both actually ended up landing right side up. They didn't have to use the rover flip. This is a drawing of what the Spirit and Opportunity look like. They are solar powered. These are the panels here. They have cameras up on the top, both for navigation and for imaging, and then various instruments, including some on a robot arm over here. They have 6 independent wheels that allow it to track across the Martian surface. So they both landed in January of 2004. This is the view from the Spirit lander in Gusev craters. And you can see the typical orange-red color that's caused by iron oxides, sort of rusty type compounds on the surface of Mars. But one thing is just to kind of realize that you're actually looking at the surface of another planet, and a planet that never comes closer than about 35 million miles away. It's really remarkable that we have these kinds of results from these robots. Here's a wider angle view of Gusev crater, and you can see how rocky it is there, but also that the sides of the crater have been worn down and carved out, and that means that the rovers can examine some of the structure in the side, just like you can on a road cut, gives you some indication of what the past history has been here in this location at Gusev crater. The rovers were slated to run for 90 days and go about 4/10 of a mile. The Spirit rover went for over 6 years and over 4 miles, just under 5 miles. So it was a tremendous engineering job that allowed these remarkable machines to function for that long. So Spirit over 6 years. This is the view from orbit where we can actually see the last spot, the resting place of the Spirit rover. In 2010, it got stuck in some sand, and before they could get it loose, the winter came and froze the Spirit rover out. They were not able to revive it. They still had a couple of possibilities for getting it loose of the sand, and it did function as a standing laboratory lander for a period of time before the winter finally froze it out. The other rover Opportunity landed on a different place on Mars, the Meridiani Planum, and this is the view, early view from there. You can see the solar panels and the arm. These are the bounce pads. This is where those airbags hit, bounced, and sent the rover forward along the Mars plane until it came to a graceful stop. One of the early findings from the Opportunity rover were these things that are called nicknamed blueberries, and they're little dots here on the rocks in a more closer view. Now, this is enhanced color, so they have stretched the color. Things that were a little bit blue, they made a lot blue so that they could be analyzed more readily, so the contrast was better. But it turns out that these little blue globules are made of a mineral called hematite, an iron compound. And on Earth, hematite is formed in water. And it reinforces the idea that at some point there was liquid standing water for some period of time, and actually flowing water to form the beads on the surface of Mars. And here on the side of Endeavour crater is another look at the stratigraphy that you get, the ability to look essentially back in time on Mars from the current day up here to progressively early and earlier times, as you look at these different streaks that represent different eras in which the rock was laid down. So both rovers, as they moved along the surface, were looking for indications of where the water was, how long it was there, and how much there was. The water is the first element in trying to assess whether there was once life on Mars. The life that we're familiar with on the Earth is pretty much dependent upon some kind of liquid water. This is the rover family in the Jet Propulsion Test yard here back at Pasadena. These are the full engineering models, but it gives you an idea of the different sizes. This was the Sojourner rover in 1996, and the Spirit and Opportunity models. And this is the Curiosity rover that still functions today. It landed in 2012, so in August, so about 8 years ago. And you can see progressively how much bigger these machines have gotten. It landed in Gale crater, and so this is what it looks like from orbit. And the center portion here is a mountain that's 3 miles high. This thing is I think about 96 miles wide. There's a 3 mile high mountain in the center. We don't think it was built up like mountains on Earth so much as the surrounding areas were worn down by erosion over the years. First, we think liquid water, and then after that, by the winds. The object is for the Curiosity rover to start, after traveling a little bit across the surface, to climb up Mount Sharp. And as it climbs through time. So the portions on the bottom as it starts are the oldest ones, and then as it climbs up, it's getting into layers and types of terrain that are later in Mars history. Now, the Curiosity rover is much heavier. It's around a ton, I think, compared to the Spirit and Opportunity. So we couldn't use airbags on those. Instead, as some of you may recall, we had this incredible kind of landing sequence where we began with the parachutes coming down, with this thing traveling 13,000 miles an hour and protected inside what's called an aeroshell from the force of the wind on the way down. So not much wind, but at 13,000 miles an hour, it's going to cause damage. And so it came down by this hypersonic parachutes, and then some rockets slowed it down some. But then as it got close to the surface, the rover was underneath this hovering device here with the rockets on it. And it came down to the surface, lowered the rover on 25-foot long cables, cut the cables, all done automatically and robotically with no opportunity to do any changes from the Earth once it started. and then flew off about a half a mile so that the hovering craft would not land on top of the Curiosity rover. And all of that had to work during the 8 minutes of terror, the 8 minutes it took to come from the parachute deploying all the way down. You can see that it dropped off the back shell on the way down as it switched over to the rocket motors. So incredibly, this actually worked. It's just amazing. But that means that the back shell is on the surface. And so, as a poster shows, the irony is that the first real flying saucer is from the Earth, and it landed on Mars rather than the other way around. And that's the back shell. And Curiosity actually got a picture of that after it landed, because it landed not all that much farther away. Here's a selfie that Curiosity took in 2016 after it had been climbing up, began climbing on Mount Sharp. And it did this by taking several hundred pictures with a camera mounted at the end of the robotic arm. And you can't really see the arm because it was taking the pictures, but they glued all those things together to show what Curiosity looks like. You can see that there's dust all over it. Mars is very dusty. I didn't mention it, but it's powered by a nuclear thermal source. So unlike Spirit and Opportunity, it doesn't have the solar panels that present problems when the dust collects on it. It's powered by a nuclear unit in the back with cameras on the top and other instruments on the end of the robot arm. So Curiosity has been working for almost 8 years. It's on the way up Mount Sharp in a section called the Murie Buttes. You can see that this is one of the areas where the rock was laid down in strata, in layers over time. At the bottom, the rocks were made out of clay-containing materials, and clay materials pretty much have to be formed in the presence of quite a bit of water. And then as it moves up, it's moving into a regime where the minerals and the rocks are made more of sulfate materials. And as it goes even higher, and hopefully it will last still for several more years, then it will encounter rocks of other kinds of compositions. And each time, that's telling us about the conditions on the surface of Mars during that era. And it's telling us about the probable presence of liquid water and whether the water was kind of neutral or basic or acidic in composition. Another shot from the Murie Buttes, at the Murie Butte from Curiosity. And here you can see on the side of the hill as it's working its way up, how the wind has sculpted, the wind and the sand blasted the terrain. This is a picture from last Friday, and it's at a rock called, that they nicknamed Breamish. It's an unusual color, and their interest in it, color and texture. So over the weekend, they maneuvered the rover arm and put one of the instruments on it that shoots from a radioactive source, a particle of a beam of alpha particles, helium nuclei. And when they hit the rock, they put a lot of energy in the rock, and then the minerals glow in X-rays. And by analyzing the X-rays, they can tell what the minerals are made out of. They're going to follow that up by eventually drilling a hole a little bit down in the Breamish rock. And I think in the next week or so, maybe, they're going to fire, the ChemCam is a camera with a laser mounted on it, and the high-powered laser illuminates the rock, beams into the rock, and vaporizes some of the surface rock. And then the camera can analyze, with the spectrometer, can analyze the vapor and see what the rock is made out of. So that's what's going on right now today at Breamish Rock on the way up Mount Sharp. Previews of coming attractions. Now it's scheduled for July the 30th, the launch of the next rover, heavier still, a new suite of instruments, but built on the Curiosity kind of platform architecture. And so this is the Jezero crater, and that's about 30 miles across. 30.4 miles across. The rover, you may have heard by now, has been nicknamed Perseverance. All of the rovers were named by school children of various ages and winners of the contest for Name That Rover. It's scheduled to land in through here, and this is a section where it looks like a river once flowed into the crater and formed a delta here, and then flowed out again on the other side. And so Perseverance is going to be looking here with new instruments that can detect organic materials, not necessarily biological materials, but materials that contain the kinds of carbon compounds that are needed to develop life. That's scheduled to launch July 30th. It has to launch sometime between July 30th and August 15th to be able to get to Mars. It turns out the way that Mars and the Earth circle the sun, there are favorable launch opportunities that minimize the total distance every 26 months. And that launch window closes around the middle of August. So with some delays already slowing things down, everybody's hoping that this thing gets off the ground on July 30th. And if not, it's got about 2 more weeks after that. That it may be able to be launched. Otherwise, they're going to have to hold it on the ground for 2 years until the planets go around again into favorable positions. It's still a 300 million mile journey, even though the closest distance is on the order of 36 million miles. Because of course it doesn't power all the way there, it glides all the way there. But that's where Perseverance is going to land. Here's an artist's conception. You can see it looks a lot like Curiosity, but all new instruments and upgraded camera systems, again, nuclear powered. Another thing it has a feature underneath it, rides underneath it, is a helicopter, a Mars copter. And this, even though there's hardly any air on Mars, carbon dioxide atmosphere, they designed these 4-foot-long rotors to lift this 4-pound payload with a camera in it to test to see if they can get helicopters to work on Mars to extend the range of the rovers. So it'll be interesting to see how that works. They're planning 5 different flights of up to 90 seconds apiece, and the helicopter has now been named Ingenuity. Maybe the helicopter will spot Marvin. It's not clear. We don't think there are big living things on Mars anymore. It's possible that there were in the past. We'd have to be phenomenally lucky to see evidence in the fossil record from Curiosity, from Perseverance rather, but that's certainly something Perseverance is going to be looking for. So we use the rovers and the orbiters to try to understand what are the likely places on Mars where we can find water, because we're going to need it if people go there, both for drinking, for air, because we can break the water apart into hydrogen and oxygen, and then also for rocket fuel, which is hydrogen and needs also oxygen as the oxidizer. So that's coming up. The people will be following in the footsteps of the mannequin Starman that was launched aboard a, believe it or not, Tesla electric car, Tesla Roadster, in February of 2018. And by November, it had passed the orbit of Mars. Mars wasn't anywhere near there then, but still, it got to Mars, or where Mars will be. Now, this was done not only as a stunt, but because the company SpaceX is testing its really super duper heavy lifter rocket. And when they test new rockets, they don't put expensive scientific instruments in it. They often put loads like water or scrap metal. So Elon Musk decided, well, shoot, if we're going to do this, let's do it right. And he put the car with the mannequin in there. And someday, maybe not too long from now, some people will follow. And so we will come to a time, very optimistically, 2028 or later, probably rather later, when there will be astronauts deployed to Mars. So here's an artist's conception of the astronaut coming down the ladder to be the first human on a planet. And then plans from NASA are to develop Mars presence. Here's an artist's conception downstream of the first landing with a habitat and a return rocket and maybe a greenhouse dome to help grow plants for food. Excursion vehicles, the opportunity to do science by humans who are much more versatile and react to what's going on there on the surface of Mars, maybe in the 2030s or so. Now, maybe we don't wait that long. Elon Musk has plans for getting people to Mars at this point by 2024. On 2022, he's going to send 2 of the huge new rockets that he's developed, the Starships, cargo rockets, to the surface of Mars. And they will have materials and machinery inside of them, so that in 2024, the next launch opportunity, he plans to send 2 Starships, as he calls them, with people in them, and accompanied by 2 more cargo rockets, with the idea that they would start building a base on Mars that early. Now, they are limited, like everybody else, by the 2-year launch window. So if something happens and it gets delayed, the 2022 cargo rockets or the 2024 astronaut rockets, then everything gets pushed back by at least 2 years. So the caution was this could be a 5-year window from 2022 to 2027 for the cargo launch, and 2 years later, the people. We'll see. That's incredibly optimistic. But his plan is to build a town on Mars, maybe as soon as 2050, 10,000 people, maybe send 1,000 of these Starships in a fleet toward Mars as 2050 nears, and have already prepared the infrastructure with facilities for manufacturing rocket fuel, extracting oxygen and water from the surface of Mars, reinforcing the idea of how incredibly important it is to determine how much water there is on Mars and where it's located. So that he's shooting for 2050. If there's a town on Mars, you can bet there's going to be a hotel on Mars to go along with it. That means that in the foreseeable future, although downstream by decades, you might be able to rent a Mars condo. Lots of desert views available. Maybe you can get around in a Mars dirigible. The gravity is light. So maybe a hydrogen blimp kind of thing. Now, that didn't work well at all on the Earth, or there's the Hindenburg tragedy. But that's because the Earth has all the oxygen, 20% oxygen in its atmosphere, and Mars does not. So you could fill this with hydrogen, and it still wouldn't explode because it doesn't have any oxygen to sustain the combustion. So maybe that's how you would get around, and that would let you get to the giant volcanoes and explore the Valles Marineris. And then eventually, Mars will become increasingly like Earth. And after you land, you can go somewhere to get something for dinner and anything that you forgot to bring along from Earth, and maybe fuel up your Mars vehicle. So you can actually do the Mars vacation. Well, it'll be a long trip to Mars. There's got to be a lot of technology advances. Right now, the trip takes 6 to 8 months. I'm sure that'll be shortened, but it's still going to be a long trip. And it's going to be an interesting but alien world when we get there. And perhaps the most favored site on this vacation, as is true of many vacations, is when you return. Mars will be interesting, but there's no place like home. Get ready, and we'll see what happens for a vacation on Mars. This has been your tourist guide to Mars. If there are questions, I'll be glad to try to answer them.
Well, thank you so much, Rich. This was a wonderful talk and fascinating. We've got a few questions. I know we're almost at 7:30. This was supposed to last an hour. So if we go a little over, and you're welcome to leave now, or if you'd like to listen to the answers to the questions, or if you have questions to ask, please just type them in the chat window. and then we'll ask those of Rich, and we can go for a bit yet to answer those questions. So the first one is from Michael Gumpel, and he is asking, how do people know the exact chemical composition of things on Mars?
So there are a number of instruments, and they've gotten more powerful from the time of that little microwave-sized rover in 1996 through Curiosity, and then a big upgrade again with Perseverance when it lands. But let's take Curiosity. There are several different devices. There are, besides the cameras that give us a picture of it, we have that instrument that I briefly described, what is it? APX. The alpha particle X-ray spectrometer that takes some radioactive material to shoot a beam at a rock, and then the energy that's pumped into that excites the minerals, and they emit X-rays, and they emit them at different wavelengths, which are essentially like colors of X-rays. And those patterns allow us to determine what the minerals are made out of. There are other spectrometers that are on board as well, including another one I mentioned, the ChemCam, and that has a powerful laser that shoots a beam at a target rock and vaporizes the upper surface. And then the camera is hooked up to a spectrometer that looks at the light coming off of the vapor, and that tells us what the contents of the rock are. So those are two of several instruments that enable us to tell what stuff is made out of there.
Okay, we have a question from Mary Feld. She is asking, Mars is an obvious scientific curiosity, but why would one want to colonize or really spend time and money on such a barren, desolate, hopeless planet?
Yeah, why go to Mars? In other words, spend all the time and effort. Okay, well, we don't have another hour, so I'm going to do this pretty quickly. First, there is the basic drive that humans have to explore, and that's why well, throughout our history, that's what we've done, is gone to new lands. And it's always been expensive for the culture in which it's immersed. But it gets progressively more expensive as we go to the moon and Mars. But that's still one possibility. The second thing is, we are interested in whether life arose on Mars. And that will tell us a great deal about how common life is in the universe. And so the search for life on Mars is a big driver. A third thing, it tells us when we look at Mars, how Mars is aged and why, and what the same kind of processes that are present on the Earth, how they have worked themselves out on another planet. So essentially, we understand the Earth's surface, somewhat the interior, somewhat the atmosphere from studying other planets. And a fourth reason is that right now, all of humanity is stuck in one place, the Earth. And if something happens to the Earth that makes it inhabitable, hopefully that we don't do to ourselves, but that makes it inhabitable, that's the end of the species, unless we are able to have at least some kind of presence elsewhere. And the elsewhere that's being looked at is Mars, as well as perhaps on the moon. Now remember, the dinosaurs were dominant for hundreds or tens of millions of years, and their demise was, we're pretty sure, triggered by one big chunk of rock coming in and hitting us. That there are other chunks of rock out there. It's not a question of when we're going to get a big impact, of whether we're going to get a big impact. It's a question of when that's going to happen. And we're sort of interested in not having all of our eggs in the same planetary basket. So those are some of the reasons. I'll also comment that while we're doing that, the money that's spent on this is mostly spent on the ground in salaries and support, and as a result, we also get technological advances from that if you could cash them in, would pay for a huge amount of the cost of doing these kinds of things. It's been that way since the dawn of the space era, and it'll certainly be that way when we develop the technology we'll need to have people travel safely and survive on another planet.
Okay. We have a question from Michelle. She is wanting to know if the composition of the rocks on Mars are similar to those on Earth.
Well, some of them are. We saw those little blueberries or hematite pebbles, and we have them on Earth formed by the process of flowing water that dissolves the minerals, and then as the water trickles through the veins in the rock, then the minerals precipitate out as these little globules. So the hematite, generally the minerals that we're finding on Mars are, I'm trying to think if there are exceptions, and I'm not a good enough geologist to tell, but most of them are found here on the Earth. And that gives us some clues, based on what we know about Earth rocks, on how the Mars rocks formed and how they weathered. So we do know that the chemicals present on Mars, as is true of chemicals across the entire universe, are the same materials, as same kinds of atoms as what we find here on the Earth. So they have combined on Mars to form minerals that are very similar to the kinds of minerals on Earth. The Earth is bigger, it has more diverse processes, so there are a lot more different kinds of minerals on Earth than there would be on Mars.
Okay, the next question is from Michael Gumpel, and he is wanting to know, why is it so hard for rovers to dig into Mars?
Why is it hard for rovers to dig into Mars? The rovers generally don't have to dig much. They have an arm comes down, scoops a little bit. The weight of them puts little grooves, sometimes trenches, in the dust of Mars, but they are mostly designed to do other things. They do have a drill on Curiosity that'll drill into the rock, and that seems to work okay. The problem that he might be referring to is on a lander called InSight that landed in 2018, and that was supposed to do a couple different things, but one of them, it was supposed to measure the heat flowing through Mars, because that tells us something about the interior of Mars, the interior structure of Mars, the amount of the heat flow. And to do that, was supposed to be able to drill down, I don't know, I have to look at the notes again, but 6 to 9 feet, I guess, maybe even a little bit farther, and sense the heat coming up. And it's only been able to go down a couple inches. And that was a big and very unpleasant surprise to the people at the Jet Propulsion Lab and the scientists that are working on this heat flow experiment. The seismometer, by the way, I think works fine, but that's sitting on top. And the problem, they first thought maybe they just hit a rock and they could move it and try again, but then they figured out that there just isn't enough friction. The Martian surface material doesn't have the kind of stickiness that the Earth rock and dirt does, so that they weren't able to get any purchase on the rocks to push it down farther. They just kind of spun. So they tried different things. They put the robot arm on top of the drill probe for InSight and tried to get that to make enough friction to push it down, and that took it down a little bit, I don't know, maybe a half an inch or something, but not very much. So now they're trying different things. They're trying to use the scoop arm to put more dirt down the hole that they've excavated, kind of counterintuitive, and to see if they can get enough dirt particles in there that the drill bit will actually dig in and get down there. So that's the problem that they've had. And, you know, we can only tell so much from orbit. We can only tell so much from the prior rovers, depending on what they were looking for, and we're often surprised. And this was one of the surprises, that we couldn't drill down with that device as it was designed to do and go more than a couple inches. They hadn't given up. They're still working on it.
Sarah Wiley is wanting to know, does the 26-month window of opportunity to launch towards Mars also apply to the return trip home? Would it be the same window for either direction of travel?
Yeah, it's going to be basically, it is going to be basically the same. It's a special kind of motion called a Heuermann transfer orbit that's sort of, well, it loops around in the most efficient energy, and that geometry is going to be, I am pretty sure, the same in both directions. And that should mean that the launch windows are also about the same for launching from Mars and launching from Earth. And then that's why the SpaceX plan calls for their initial astronaut crew to be there at least 26 months. They're going to be, in a way, stuck there, and they'll be making their own fuel for a return anyway until they have the most favorable opportunity. So it's basically the same.
Okay. We have Deanna is wanting to know about terraforming on Mars.
Terraforming, the idea that we could convert Mars to something that's more habitable and friendly to Earthlings. We certainly converted pristine places before in bad ways. This would presumably be in a more favorable way. There is a big argument about that among ethics people as to whether we should be able to do that. But it would be a colossal engineering project to try to get facilities that would extract the carbon dioxide from the rocks and pump it into the air so that the air blanket is thicker, the atmosphere, and retains heat enough and enough pressure that liquid water could again be present on the surface. It would also provide the shielding so that humans could walk on the surface without being fried by the radiation from the sun. But that is on colossal time scale, huge amounts of processing over, the estimate I saw was 100,000 years in order to terraform. Now, the other possibility is to just take small areas, a few blocks, maybe build up to the size of a small town, put that under a dome and pump oxygen that you extract from the Martian water into the dome, and then people could live on a city on Mars, but would have to have pressurized suits when they went outside the city. That's not what's usually considered to be terraforming. Terraforming is change the whole planet, and I don't know that there's anything that makes it physically impossible, but it's a tremendously difficult and expensive thing to do that would require very, very long time frames.
Robert Sweeney is asking, he says he thought the core of Mars was frozen and therefore has no magnetic shield to protect from solar wind. Isn't that a significant problem?
Yeah, I mean, scientists are trying to understand just how Mars did go about losing most of its atmosphere and probably a lot of the water along with it. And part of the problem is that the magnetic field on Mars has decayed down to very low or zero levels. And the question is, what did that? We think that the magnetic field for planets, and certainly the Earth, is generated by masses of flowing metal, iron, and that generates a magnetic field. And so the thought was that since Mars is smaller, it would have cooled much faster, and early in its history, then the molten metal in its core would have become solid, would have cooled and become solid, and shut down the magnetic field, and then the particles and energy from the sun start to blow away the atmosphere. So the core of Mars is solid, and I think that's what was meant by frozen. And that means if we try terraforming, we would have to do something either to continuously generate the atmosphere that's lost, or find some way of generating a planet-wide magnetic field. And I don't think we have a clue as to how to go about doing that yet.
Okay, Chrissy is asking, is it true that rock from Mars has landed on Earth? If so, how would that happen where it could escape Martian gravity and find its way to Earth?
Yes, we definitely have Martian meteorites. I think there's one at the St. Louis Science Center that you can go and look at it in the case. I'm not sure if that's the one that's set up that you can actually touch it or not. But there are, I don't I don't know, a couple dozen, quite a few little pieces of Mars on the Earth. So we know that they're from Mars because they have trapped within them tiny little pockets of gas. And when we look at what that gas is, and in detail, it matches the composition of the atmosphere of Mars. So those are called SNCs, and that's an acronym that I don't remember how to decode. That are that whose origin is from Mars. So they pieces got here by being blasted off of the surface of Mars by presumably very high energy meteoroid or asteroid strikes. And those dug out the holes that made the craters, but they could also blast material off the surface of Mars, and it zips around through space. We're able to tell how long the meteorites have been in space. I think they do that by looking at cosmic ray erosion and damage. And then after the one sample that I'm thinking of, a couple million years, it strikes the Earth and somebody finds it, and then somebody thinks it looks unusual enough to analyze it and get the chemical composition that's a match for Mars. So that's how it got here. That argues that there could be pieces of Earth that were blasted off to Mars. That'd be harder because the Earth's gravity is much stronger and you're moving away from the sun instead of falling in toward it, but it's certainly highly possible. We have meteorites from the moon from the same kind of mechanism. Most of the meteorites are from asteroids way out in the solar system.
Okay, we have Trinity, who is wanting to know if youth can be involved in studying for Mars exploration, and is there a way to be a part of that?
Would you repeat that again? She wants to know how to?
Right. So can youth be involved in studying for Mars exploration? And is there a way to be a part of that?
Okay. Well, SpaceX certainly thinks that there is, and we should find out in the next 10 years or so how successful they're going to be with that. If they're going to build a city of several thousand people, then they'll be recruiting to have people do that. NASA has a program. I don't know if it has very specific time frames on it yet. I think 2028 was mentioned. That seems pretty optimistic to me. I had a note on that once, with the return to the moon being 2024 and then 2028. So downstream, NASA version program for Martian exploration. Gee, in order to get into that, it's really difficult at the opening stages. I mean, they're going to need geologists, they're going to need scientists, they're going to need a lot of engineers to become involved with colonization. I think if you're interested, it's the case to look into some NASA sites. I don't know how many are developed at this point yet, and to look at some of the commercial ventures, and SpaceX is the big one. There are other companies, but they are mostly focused on near Earth projects, orbiting factories, hotels, downstream a little bit to return to the moon.
Okay, and I do want to mention that one of our members mentioned that they might want to look up CosmoQuest, which is a citizen science opportunity and site for all ages. They can analyze photos of Mars and other celestial bodies at home on your computer. So that's CosmoQuest. You can just Google that and you'll find the website.
There was a program called Mars One that was recruiting worldwide to have people sent on a one-way trip to Mars in the early 2020s. That they were not able to get the funding for that, and that had to close down in around 2016 or so. So there are companies that are going to try it. It's going to be really hard to be successful at that, but SpaceX is certainly the leader. And then, as you mentioned, the citizen science sites give you the opportunity to participate in the kinds of science research in which you're interested in real time from your home.
We've got one last question. Is there any evidence that others have visited Mars?
Is there any evidence that others have visited Mars? No. The face on Mars and the cities on Mars, once we had better cameras, they were clearly shown to be natural formations. We certainly don't see the remains of any civilizations there. We don't see any indication that there is presently life on the surface of Mars. It would have to be extremely hardy, and we think it would be down at the level of microbes to be able to survive. We don't know if it's possible that there could be life underground in caverns on Mars or in the lake. And as far as any kind of evidence on Mars or on the moon that there are beings other than humans and beings that have gotten there already, then we certainly haven't seen any indications of that.
And I think that's it. Unless anybody else has a question, we will wrap things up. And thank you all for joining us this evening. And thank you so much, Rich, for being gracious and joining us tonight. This is fascinating and fun talk. We do plan on having more of these happy hours on science, so we'll be scheduling those in the very near future. So if you're not signed up to receive our e-news, please visit our website. You can sign up to receive e-news on our website at academyofsciencestl.org. You might also want to visit us on social media, Twitter, Facebook, and Instagram. So let's see, we've got one more question. Let me look here. I think that is it. Okay. Well, thank you all for joining us, and we're gonna end our virtual happy hour and enjoy the rest of your evening. Thanks, Rich.
You're welcome. Bye.
Night,
Cheers.
everyone. Yep. Cheers. Good night, everyone.